So here's a question for you guys. When you run a command in Bash, then how do you know if it was successful or if it failed? Well, I think the obvious answer here is that if you see an error message, then I think it's, well, quite obvious that the command failed. But how we actually determine success or failure in Bash is not quite the same way in which we do that in real life. There's also the concept of exit codes. And what exit codes allow us to do is actually determine whether the command that we've just entered was successful or if it was not successful. But in my opinion, the best way to learn something is to see it in action. So let's dive in and actually see exit codes in action. And by the end of this video, you'll actually understand exactly what they are. Let's go ahead and dive in. In this episode, we're going to take a look at exit codes. Exit codes help us determine whether or not a command was successful. Now, to be fair, we can often use common sense to determine when a command was successful. So if I type ls-l against a directory, then we could probably safely assume that this command in particular was successful. I mean, we did see results, we didn't see an error message, so the command was successful, video over, we're all set, let's move on to the next lesson. Well, actually, it's not quite that simple. Yes, that logic often does work out, but according to Bash, whether or not a command was successful may or may not be the same as our understanding as human beings, whether or not a command actually was indeed a success. Now, similar to that, if I run ls-l against another directory, this time I'll choose the misc directory, I'm getting an error message. It's telling me that this particular directory does not exist. Now, it doesn't take a computer scientist to know that the command failed. I mean, it's literally telling me right here that there was a problem. So obviously, there's some sort of error, the command didn't work. So I think we can be reasonably sure that this command was a failure. But so far, we've been determining whether a command was successful or not using nothing but our own judgment. So how exactly does Bash represent success or failure? Well, for that, Bash provides us with a special variable that contains an exit code, and we could view the exit code of the most recent command to see whether or not Bash interprets that command as being a success or a failure. And that's what the exit code actually does. It lets us know whether or not a command was actually successful or if there was some sort of problem. For example, let's list the storage of the etc directory yet again. And directly after that, what I'll do is use echo to print the contents of that special variable that I was telling you about, which is actually $?. And this variable, believe it or not, even though we didn't declare it, it was already declared when we entered the previous command. And this variable right here contains the status of whether or not that command is considered a success. So I'll press enter, and we get an exit code of 0. But what does that mean? Well, let's run a quick experiment. What I'll do is list the storage of an invalid directory yet again. And now let's check the exit code this time. Remember, last time we received a 0, so what does a failure look like? Well, in this particular case, it's showing 2 for the exit code. So the first command, which worked, gave us an exit code of 0. The failed command gives us a different number. So what exactly does that mean? That's actually the easiest part of this entire lesson. I could summarize the difference in a single sentence. An exit code of 0 means that the command was successful, and an exit code of anything other than 0 constitutes failure. The first command, ls-l against the etc directory, worked just fine. It gave us the results that we were looking for, and we especially know the command worked because the exit code was 0. The second command gave us 2, which is non-zero, so that means that command in particular was not successful. However, why do we need to know what an exit code is? I mean, it's pretty obvious when something fails, right? If we get an error message, the command failed. If not, that means the command was successful. Well, the issue is that when we write scripts, we write them such that they can run by themselves without us needing to watch them. Normally, scripts run on a schedule. For example, a backup script that kicks off at midnight every night. In that case, I'm assuming we'd rather not wake up at midnight to make sure that the script executes properly. So basically, with an exit code, we could check for a non-zero exit code and take action. With the backup script example that I just came up with, if that fails, it'll exit without the exit code being 0. Then something can run right after that, such as, well, a command to email the system administrator, maybe that's you, and let them know that something went wrong. Maybe in your case, it's perfectly acceptable to go ahead and check the following morning if something was a success or not. And if you see that something failed, like an email in your inbox with an error message, then when you get into the office or you connect to the office, you could go ahead and fix the problem. Now let's see some script examples that utilize an exit code in some way. And here we have the script that we've been working with. I'll go ahead and empty it out. So what I'll do is create a variable. I'll name it package. I'll set it equal to htop. And then what I'll do is type sudo apt install and then the name of the package. After that, what I'll do is type echo, and then I'll say the exit code for the package install is, and then $, just like that. So I'll save the script and exit out. And what I'll do is actually remove htop from my system. Otherwise, the script isn't going to have anything to install. I'm telling it to install htop. It's already installed, so I'll just go ahead and remove it. So we'll finish that. And let's run the script. Now, it went ahead and installed htop for us, but pay special attention to this last line right here. This here is what I echoed. I also echoed the contents of the $? variable that, if you recall, contains the exit code, and the exit code is 0. That's great. That means that the command within the script that we're checking was a success. And with this script, we can start to see the value of exit codes. Like I mentioned earlier, if something was to fail, maybe you want some sort of action to be taken. I used an example of email, but maybe you might want a log file to be updated that you'll check later, or some other action to happen as a result of failure. Now, just to make sure that the script is actually working as well as I think it is, let's bring it back up, and I will change the name of the package to something completely different. I'll change the name to something that doesn't exist. There's no package named not exist, so I'll save it. Let's go ahead and run it. And the exit code this time was 100. It's not 0, so that's a failure. Even though I made that failure happen on purpose, you could probably see why exit codes are going to be valuable in the future. So let's go ahead and update our script so that way it's able to better utilize the exit code, and that'll also be yet another example of why exit codes are actually a good thing. So I'll change this back to htop. And I'll leave this line alone right here. And I will delete this one. Let's go ahead and start a new if statement right here. So I'm going to check the $? variable, the exit code. I'm going to see whether or not that equals 0. Then, what do I want it to do if it does, in fact, equal 0? Well, what I'm going to do is echo something. The installation of package was successful. Then what I'll do is type echo again. The new command is available here. Then we'll use the which command against package. That'll show exactly where that particular command is located, the fully qualified command. But that's all well and good, though I think we should probably do something if it's not successful. So what I'll do is type else. Now with else, if the exit code does not equal 0, then we want to do something else. Hence else. We're going to print package failed to install. So I'll save it. Let's remove htop. And let's run the script. And we can see that it did in fact install htop, and then at the end it's printing the statements here that were associated with the success. The installation of htop was successful, the new command is available here, and then it executes which htop, which gives us the path, the fully qualified path to the command. So that part worked just fine. And to further test this, I will change this yet again to not exist. And let's try this again. Not exist, failed to install. Well, of course it failed to install, there's no such package, but you get the idea. This particular script is actually taking the exit code into account here. If it's equal to 0, which again means that the command was successful, it's going to tell us that, and then it's going to give us the path to the command, but if for some reason that failed, it's going to let us know that it failed. Now obviously the output of the apt install command, that actually absolutely failed. It doesn't take a rocket scientist to know that, but this was just an example of how we can make the script do something different depending on what the exit code was of the command. So what I'm going to do now is change this script to make it a bit more realistic, basically more like a real script that you would actually find on a real Linux system. Again, it's not going to be the most useful script in the world, but we're getting closer and closer, and we're definitely getting closer with this example when I change it, so I'll go ahead and do that. So right here at the very end of this line, what I'm going to do is type 2 greater than symbols, and I'm going to type a file name here. And you can name this whatever you'd like. It doesn't matter at all. I'm just going to create a file named package_install_results.log. Now notice here that I have 2 greater than symbols. This is a redirect. This is something that we'll be using as we get further and further into the series, but this is the first time that you've seen it in this series. So rather than print all of the information on the screen showing the process of the package being installed, what I want to do instead is redirect that output into a file. The 2 greater than symbols, what that's going to do is append the output of a command and send that output into a file. So when we run this command, we should find this file right here. I will also change the package name back to htop. And then what I'm going to do, I'll add 2 greater than symbols here as well. And I will create a sort of failure log for this particular script. It is just going to send this message right here into that file. So if this works, nothing should be printed on the screen other than what I'm telling it to print right here. So that way we won't see the wall of text scroll by when we run this. Now, assuming I didn't make any errors, this should work just fine. First of all, I will again uninstall htop. And you could use whatever package name you want to, it doesn't really matter, but let's run the script and see what happens. Hopefully I didn't make any errors. We can ignore this warning right here, that's just from apt. But it's telling us that the installation of htop was successful and the command is available right here. So we see a lot less output here than we saw the first time. And check this out, we have package install results.log. If I was to cat that out, that's all the output that I would have seen if I didn't redirect the output of apt install into a file. I did, so all of this is in the file. But this just helped us actually clean up the output a bit so we don't see a wall of text. We see mainly only what we need to see. So similarly, what I'm going to do, just like last time, we want to make sure that we test all of the scripts that we write. So I'll change the package to something invalid again. Let's exit out of here and run it. Now right here, it's telling me that it's unable to locate the package. But the interesting thing is that I redirected output to a file, so why am I still seeing this? We'll cover that later in the series. So what I would do is just completely ignore that for now. There's a perfectly valid reason why that's the case. We will get to that. But let's go ahead and list the storage. We now have the package install failure log file here. And it's telling me the name of the package, which I made invalid on purpose, failed to install, just like we expected. Now what I want to do is show you guys a very important example when it comes to exit codes, because this is something in the real world that might actually bite you and frustrate you. And I want to get this out of the way right now. So this is really important. So what I'm going to do is create a brand new version of our script, and I'm going to clear it out. And what I'll do is create a variable named directory. In my case, I will set that equal to /etc, just like that. I'll start the if statement, and I'll check for the existence of a directory. That's what -d is right there. And I'm checking for a directory. I'm just going to use the variable name right here. Let's close out the test. We'll type then. We'll echo the directory, and then the variable exists. Else, if that's not the case, we'll echo a different statement. The directory and the variable name doesn't exist. Okay, so far so good. Now the last line in this particular script will be yet another echo statement. The exit code for this script and this particular run of the script is, and let's print the exit code right here. So let's save the file and exit out and run the script. The directory /etc exists. The exit code for this script run is 0. So at first glance, everything seems to be perfect. We have a script that's checking for the existence of a directory. The directory that we're checking the existence of, it does exist, so this is not lying to us. And it's telling me that the exit code for this particular script run is 0. Well, that makes sense. I mean, the directory is there. We know that it's there. In fact, I could prove it by typing manually ls-l/etc. It worked. So far, we might be under the impression that this script is fine, but it's not. Do you know why this script is wrong? I'll give you a moment to think about it. You can pause the video if you want some more time to think about it, but whenever you're ready, we'll go ahead and continue. Okay, so let's continue. So here's the script again. And what I'm going to do is change the directory to /notexist. I want to force a failure here. So we definitely shouldn't get an exit code of 0. Let's save the script and let's run it and see what happens. The directory .exist doesn't exist. The exit code for this script run is 0. But wait a minute. An exit code of 0 means success. But this wasn't successful. What's going on here? Let's go ahead and edit the script again and see if we can spot where the error actually is. So here we have the statement that the exit code for the script run is, and it shows the exit code, which we got a 0 for some reason. Let's go ahead and just test this out. And what I want to do is type right here, echo, then $?? I'll do the same thing here as well. And let's see what happens. Now, immediately we see an exit code here of 1. That is an unsuccessful exit code. But by the time we get down here, the exit code is now 0. Why is that? Well, here's why. So what I'll do is just take out these extra echo statements, return the script back to what it was. Even though the check right here, where it's checking to see whether or not this directory is present, in this case, I set it to .exist. So right here, the exit code is not going to be 0. This was not a successful test. Now, right here, this echo statement, this is successful. It was actually able to echo something. So this statement, no matter what, is always going to have an exit code of 0. It was able to echo. That worked. So exit code 0. If the directory doesn't exist, it's going to move down here to else, and it's going to echo to let us know that the directory doesn't exist. But that echo was successful. Even though it's telling us that there was an error, it was successfully able to echo to our terminal. So that is also going to get an exit code of 0. That's why when I put an exit code above the echo statement, that's where the exit code actually matters. Not after the echo statements. Those echo statements are fine. They're going to run. But if we check it before the next command runs, then we're going to see the real exit code, and that's why we were able to get a different exit code. But at the end of the script, we get an exit code of 0 because the echo statements will run just fine. So the moral of the story here is that when you want to differentiate what happens in a script based on the exit code, you'll need to make sure that you're checking the exit code at the most appropriate time. Definitely do some extra testing anytime you're utilizing the exit code in this way when you're checking for something. You'll definitely want to make sure that you simulate an error, so make an error happen on purpose, and then you could test to see whether or not the script behaves appropriately. But there's actually another way that we can handle this situation. So what I'm going to do is write a different script, and what I'm going to illustrate is that you have control over what the exit code ends up being. So yet again, let's clear out this script and start from scratch. So I'll type echo, I'll type hello world, and right after that, just like we've seen, I will echo the actual exit code, which should always be 0. So it shows hello world and 0, exactly what we were thinking was going to happen. Now what I'm going to do right after hello world is I'm going to type exit and then number 1. So this is going to be interesting. What this is going to do is force the exit code to be 1 no matter what. So I'll save it yet again. Let's run it. And it only prints hello world. It didn't actually print the exit code. Okay, that's interesting. Let's go ahead and just check the exit code manually. Just like we've done before, the exit code is 1. Okay, well, so far so good, right? So what I'll do here is exit 199. I just make it totally stand out. So I'll minimize that, let's run it. And the exit code is exactly what we told it we wanted the exit code to be. So similar to that, what we could do, if I bring that up yet again, I'll just go ahead and run sudo apt install not exist. We'll set the exit code to 0 right here. Let's save the file and run the script again. We're just playing around with exit codes here. That's a good thing to do. That's how you learn. Unable to install package not exist. But we have a successful exit code here. Well, we forced that along. So if I bring up the script again, right here I'm typing exit 0. Now what exit will do is exit the script with whatever exit code you actually type here. And that's why this line never runs. This line right here is actually supposed to give us the exit code, but it never does that because this line right here, it actually exits out of the script. Nothing else will be run. No matter what we type here, it's done. On that second line of the script, it's going to exit. It's going to exit with an exit code of 0. That's it. So this statement right here will never run. Let's go ahead and change this up a bit. And for the next script, what I'm going to do is set the directory back to etc, just like it was before. So if we're going to test to see whether or not that directory exists, then we'll echo. And here we're going to force an exit code of 1. And we'll just echo another statement right here. And then I'll add another echo statement. Why not? And another. So there we go. Basically, the previous version of the script, I've just added a bunch of different things here. For example, I'm going to set the exit code to what I want it to be within the if statement. And then I have some statements down here at the bottom. And I think you probably know exactly what's going to happen here. But let's find out. The directory /etc exists. Well, we know it does, right? So if I bring up the script again, notice that these 3 statements didn't run. Even though I had exit within the if statement, and I have it in both sections, underneath then as well as else, that's going to exit the entire script. It doesn't matter that the exit is within an if statement, exit means exit. It's going to absolutely exit. That doesn't mean it's going to break out of the if statement and then continue to run the other echo statements that are down here at the bottom. Exit, like I said, means exactly that. It's going to exit out. And we don't actually have to give it an exit code. We could just simply exit. But what I like to do is give an exit code within the if statement, so that way I have actual control as the creator of the scripts, what the exit codes are and what they mean. So I could create an exit code of 199 if I wanted to, and then I could look for that specific exit code. I have full control over this, which is what this allows us to do. So with exit codes, we're given more control over our scripts, and we could actually create the scenario that we want to check for. So if it gets down here to else, it's only going to get down here if there's a problem. That's the only scenario that's going to create this particular outcome. So I want to give it exit code 199 because maybe this particular section of the script, 199 has special meaning to me. And now I can make that whatever I'd like. Again, we'll understand this better as we get further into the course. But for right now, that was a lot. So there you go. Yet another video in this series is all set, and I hope you're not moving along too fast through the series. But in this video, I taught you guys exit codes. It's a very important topic, and I hope it helped you out. If it did, then please click that like button, as always, to let YouTube know that I helped you out. And I'll see you in the next video, which is actually already uploaded. So I'll see you there.